Hey y'all, in this lesson we're going to take a look at solving two-step inequalities. By the end of this lesson we want to be able to say, I can write and solve two-step inequalities. Before we look at our essential question, let's take a look at some important information to remember from last time. The method for solving inequalities is just like the method for solving equations. Again, you'll want to fill in the blanks with the underlined words. The only difference is when multiplying or dividing both sides of the inequality by a negative number, you must flip the inequality. Our essential question is very similar to the essential questions from lesson 1 and 2. It is, how is solving a two-step inequality similar to and different from solving a two-step equation? Let's take a look at a couple examples of solving two-step inequalities. First, we have 3x plus 5 is greater than 11. Remember from solving equations that when we solve a two-step inequality, we're doing the opposite operation in reverse order. So if I multiplied by 3 and add 5, the first thing I'm going to deal with is the adding 5. And the opposite of that is to subtract 5. So drawing my line down the middle, I will subtract 5 on both sides. That will leave me with 3x on the left, 6 on the right, and my symbol, the greater than, is going to drop down. Now I am just multiplying x, so to undo that, I'm going to divide. I'll divide by 3 on both sides of my line. On the left, I'll be left with x. On the right, I'm left with 2. I still have my greater than symbol since I divided by a positive number. So my answer here is that x is greater than 2. Looking at our next example, if I put in a number for x, I'm going to take 8 and subtract that number. Well, I can kind of rewrite this. And I can rewrite this as being 8 plus -1 times x. So I can see here that if I put in a number for x, I'm multiplying by -1, and then I'm adding 8. So I want to do the opposite of those things in the reverse order. The last thing I said was adding 8. So that's the first thing I'm going to take care of. I will draw my line down the center, and I will subtract 8 on both sides. When I do that, I am left with negative x on the left, and 14 minus 8 is 6 on the right. I still have my less than or equal to symbol. Now I need to get rid of that negative with the x. So I am going to divide everything by -1, because remember, this is like -1 times x. So I'm dividing it to get rid of it. I've divided by a negative number, so now I need to flip my inequality, so you see it has gone from less than or equal to greater than or equal to. I'm left with x on the left, and 6 divided by -1 is -6. So my answer here is x is greater than or equal to -6. Let's take a look at a problem with word problems and see how to write an inequality and then solve it. Hamish has $25.97 in his pocket to spend at the craft store. He wants to buy a paint canvas and some paint pens. How many paint pens, P, can Hamish buy? We can see that the canvas is $14. We can see that the paint pens are $3.15 each. Well, we want to write an inequality to represent this situation. We've got $25.97. We can't spend more than that. So the amount we spend has to be less than or equal to that. So the cost of our canvas plus the cost of one pen times the number of pens we get has to be less than or equal to the amount of money we have available. Well, the cost of the canvas is 14. The cost of one pen is $3.15. And the number of pens will be P, we don't know yet, and that needs to be less than or equal to 25.97. You might write this a little bit closer together, and it might look like 14 plus 3.15p is less than or equal to, I don't have that kind of a button on my computer, 25.97. So you can see it wouldn't be all spread out like this, and we would do 3.15 times p as 3.15p. Let's take a look at solving this. So if we solve this and then graph it, if we solve it, it's really just a two-step inequality where we need to first subtract 14 using the subtraction property of inequality. When we subtract 14, we'll have 3.15p is less than or equal to 11.97. Then we'll use the division property of inequality and divide by 3.15 to get rid of it on the left. We'll be left with p is less than or equal to 3.80, or the number of pens is less than or equal to 3.8. We can graph this on a number line by showing about 3.8, and my arrow is now pointing to the left for less than numbers. Now we need to remember, only whole numbers are solutions here because I'm not going to have 0.8 of a pen. So Hamish can purchase only whole number of paint pens, so he can buy 3 or fewer paint pens. Because 4 wouldn't work. 4 is not less than 3.8. So he can buy 3, he can buy 2, or he can buy 1. So again, we set up our inequality, we solved it using the two steps of subtracting and dividing, and then we interpreted our inequality, our statement, our answer, so that we could answer the question. You try two problems. One, a plain old inequality to solve, and the other being a word problem. Pause the video now, try these two problems, and press play when you're ready to see the answer. Hopefully for this problem, you got x is less than -50. For the word problem, when we set it up, we're going to have the cost of our vase plus the cost of our roses has to be less than or equal to the money she has. So $11.75 plus 3.50R is less than or equal to 52. When we solve this, we get that R must be less than or equal to 11.5. She's not going to buy 0.5 of a rose, so she can buy up to 11 roses. Your summary, solving two-step inequalities, is just like solving two-step equations. You carry out two different operations, usually addition or subtraction, and then multiplication or division. However, unlike equations, which have a single solution, our inequalities will have multiple solutions. Like I said with Hamish, he could buy 3 pens, he could buy 2 pens, he could buy 1 pen. There are multiple different numbers. Your next steps are to submit your 4.3 notes to Schoology, complete your 4.3 practice on Schoology, and then take your 4.3 mastery check. Good luck, and I'll see you in the next lesson.